Hey guys, thought I would post a video of me going over the Chapter 7 review, and I hope you guys find it helpful. Alright, so the first couple questions really is just using antiderivatives, and you'll see a couple of these on the test. So for number one, when it says find the general solution, remember that you should be looking to have plus c at the end of your answer. And exact differential equation just means here's an equation that's a derivative. Alright, so right away, so I'm going to take the antiderivative of both of those terms. So if I integrate both sides, this is going to be y, and then on the other side, the antiderivative for cosecant squared is negative cotangent of x. And then for the next term, we'll have minus. Now this has to be x to the 7th. And then I'm going to divide this by 7 in order to account for that power rule that's taking place. So that should be just 4 plus c. Always remember that once you have your solution, remember that if you take the derivative of this, it should be this right here. So always remember, if you want to check your work, make sure that whenever you get this, the derivative should be this right here. Alright, for the next one, so we'll anti-differentiate, integrate both sides, so I'll get u is equal to, I see that right there, well, that's going to just be 5t as the antiderivative of that term right there. And then this one looks like it's going to be complicated, but that's why I put this in here so that you guys can get used to it. That is just going to be, that is a result of the derivative of sine inverse, or arcsine. So plus sine inverse of t plus c. For 3, integrate both sides, so I get y is equal to, for this term right here, might be helpful if you look at it as x to the negative 1/2. So I'll increase the power by 1. So I should have x to the positive 1/2. And then I would have to, in order to get the constant of 6, I believe that should be 12. Right. Because from here, when I take the derivative, I would bring down the power, and then that would turn into a constant of 6. 12 times 1/2 is 6, so yeah, that works. And then, again, this one might look a little complicated. This expression is just the derivative of tangent inverse, so minus tangent inverse of x and plus c. And yes, I will be making sure that you have plus c for anything that needs it. Alright, so for 4, evaluate the integral of this expression right here. Just looking to do some simple antiderivatives. 5e to the y, antiderivative for e to the y is e to the y. So this remains 5e to the y. This expression right here, you have minus 5 cosecant y, cotangent y. That looks like it's a result of the derivative of 5 cosecant y, I believe. That should probably be positive, though, because the derivative of cosecant is negative. So it starts positive, but then it would have to become negative. So there's that right there. For this term, again, I like to write those. That's going to be to the power 1/2. That's the same thing. So when I anti-differentiate that, that's going to be increased by 1. So that's going to be plus y to the 3/2. And I want the constant to be 2/3 since there is no constant here. So that when I take the derivative of this, the constants will cancel. Plus c right there. Now for 5, solve the initial value problem. Same process. except I need to find a value for c given a y and an x value. So anti-differentiate these, so that's going to be y is equal to, well, to get sine with a derivative, I think you need negative cosine. So you'll have to have a negative cosine of 2x plus pi. Now also keep in mind that this has a constant of 2. So inverse chain rule would say I would have to multiply by 1/2. And then we would have plus some constant. So in other words, we would have y is equal to negative 1/2 cosine of 2x plus pi plus c, if you need to double check. Well, okay, so that's a constant. Well, derivative of cosine is negative sine. And then we would have 2x plus pi. And then you'd have to take the derivative of the inside, which would be 2. So multiply by 2. Don't forget that we had this constant out here, that's negative 1/2. So you can see that this negative would cancel with this, and then this 1/2 would cancel with this, and it would just leave me with sine 2x plus pi, which is what we have here, so it looks like we have the right derivative. Okay, now I'm going to plug in 5 and 0 respectively into y and x, and then I'll find the value c. So this is 5 is equal to negative 1/2 cosine. If I plug 0 in here, it's just going to leave me with pi. So cosine of pi plus c. So 5 is equal to negative 1/2 cosine of pi. If you think about the graph of cosine of pi, it looks like this. And halfway would be pi. So you could see at pi, it's going to be negative 1. So negative 5 times by 1/2 times by negative 1, and then plus c. So this will result in just 1/2. So I get 5 is equal to 1/2 plus c. I'll subtract 1/2 over there. Now I'll make this a denominator of 2. That's the same thing as 10/2. And then minus the 1/2 from the other side is equal to c. So c would be equal to 9/2. And so going back to this, my exact solution should be y is equal to negative 1/2 cosine of 2x plus pi plus 9/2. Okay. Doing the same thing up here, looking to solve this one. So 2 over t, so, well, first, okay, we're going to integrate. Just notice the variables, so you're looking for x with respect to t, so x is going to be equal to 2 over t, that looks like it's going to be 2 natural log of t. Now, this term right here would be equivalent to t to the negative 5. So whenever I anti-differentiate, I need to increase the power by 1. So that's going to be, I think that should be plus now. This is going to be plus because that exponent is negative. So when I take the derivative, that negative has to drop. And then that should be t to the negative 4. And then I would need to divide by 4. So 1/4. Just to do a quick check, so if I take the derivative of this, I would drop the negative 4 down. That would make it negative, which it is negative. It would cancel out so 4 divided by 4 would be 1, which is good because that's the constant that I have. And then I would decrease this power, which would then turn into negative 5, which is what I have. So I believe that is correct. But that being said, I am going to put this as a fraction, so t to the positive 4. Okay, plus, and the derivative of a constant would be 2t, so plus 2t plus c. Okay, so now I need to plug in my value, so x is going to be 9, t is going to be 1. 9 is equal to 2 natural log of 1 plus 1 over 4, because that's just going to be 1, plus 2, plus c. So 9 is equal to, natural log of 1 is 0, so that's just going to be 0 right there. So I'll be left with 1 over 4 plus 2 over 4. Now, 2 over 4, plus 2. Well, 2 is the same, that would be 8 over 4. Okay, oh, sorry, I forgot my plus c. So plus c. I'm going to write this as over 4. That's going to be the same thing as 36 over 4. So I got 36 over 4. And I'm going to subtract the 1/4, and I'm going to subtract the 8/4. That's going to be equal to c. And 36 minus 9 is going to be 27. So c will be equal to 27 over 4. So my solution will be x is equal to 2 natural log of t plus 1 over 4 t to the 4th plus 2t plus 27 over 4. Now, I'm pretty confident that I did that problem right. But if you guys are using your key, just a heads up, I'm pretty sure that, so down here, yeah, so they found the constant to be 5, which I am not entirely sure how they got that, because no matter how many times I've tried it, I've gotten 27/4. But if you guys figure out that it is 5 and I did something wrong, feel free to let me know. And this t is greater than 0. It's just due to the fact that this function might have one, it's due to the fact mainly because there's a restriction of natural log of t. Natural logs have a domain of x is greater than 0, so that's why that's there. Am I going to be looking for that on the test? No, I'm not. If that question were on the test, or if there's a question like that on the test, I'm not looking for that portion. But feel free to put it if you feel like you need to. Alright, slope fields. Dy over dx is equal to x squared minus y squared. So, just so you guys know, this is to represent a grid, or a, pretty much like a grid, where this is the origin 0, 0. This will be -1 for x, 0 and 1 for x. This would be 2 for y, 1 for y, 0 for y, -1 for y. Just so you guys know. And it wants us to generate a slope field. So what I like to do for these ones, I'll make like a table. So xy, I'm going to call this y prime. And then I'll start with this row right here. Notice that here, x is always -1. So x is -1. And then I'm going to plug in 2, 1, 0, and -1 to find what the slopes are. Okay, so since in this case x is always -1, that means -1 squared is always 1. So 1, 1, 1, 1, minus, 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 and then this part is going to be, so in this case it's 2 squared, so it's going to be -4. This is going to be 1 squared, so it's going to be 1. If I plug in 0 there, it's going to be 0 squared, which is going to be 0. And if I plug in -1, that's still going to be 1. Okay, so that's equal to -3. That's equal to 0. That's equal to 1. That's equal to 0. So we have 3, 0, 1, 0. So I'm going to do my best to give a rough sketch. So at this point in particular right here, we'd have a slope of 3, which is kind of steep, so maybe something like that. And then here we'd have a slope of 0. We'd have a slope of 1, so maybe just like that. And then we'd have a slope of 0. Okay. Let's go ahead and go to the next column. So in the next column, well, I can keep that y there. But in this column right here, we would have x is equal to 0. Okay, so that means for our y prime, well, if x is 0, 0 squared is just going to be 0, so we have 0. And then minus 2 squared is going to be 4. 1 squared is going to be 1. 0 squared is going to be 0. Negative 1 squared is going to be 1. So it's going to be equal to negative 4, negative 1, 0, negative 1. So at this point, we're going to be negative 4, which is steeper than it was here, because I believe that was negative 3. So negative 3, okay, then we're going to have negative 1, we're going to have 0, and we're going to have negative 1 again. And then for this one right here, x is going to be equal to positive 1. Okay, I'm just going to change this part, because that's always going to be minus 4, minus 1, minus 0, minus 1, and then 1 squared. So if I plug in 1 for x, 1 squared is always going to be 1, so 1, 1, 1. Okay, let's go and change this right here. So here this is going to result in negative 3, 0, 1, and then 0, which is just the same as we had over here. So maybe just like a steepness of negative 3, 0, 1, and 0. And there we go. So there is our slope field. Okay, for the next one, it says use Euler's method to solve the initial value problem. So it gives us the derivative, which is y minus x, and it tells us the initial point is y equals 2 and x equals 2. So if you guys remember, I shared a method where I use a table. And this is, I found, the best way to go about this Euler's method. So in this table, I'll make a table of x and y values, and then in this column right here, I put in the value of y prime multiplied by dx plus y. Well, in this case, y prime is given as y minus x, so we'll do y minus x multiplied by your change in x. Your change in x is given to you right here. So use Euler's method with increments of delta x equals negative 0.1. So this is always going to be negative 0.1 and then plus y. And we're starting with 2 and 2, and I like to do this part first. So since x is starting with 2 and we're trying to approximate when x is equal to 1.7 with these with increments of negative 0.1, that means my next x value is going to be 1.9, then 1.8, then 1.7. Okay, and our goal is to find the value that we end up with right here, because that's the y value when x is 1.7. Okay, so we'll start here. So y minus x, in this case 2 minus 2 is going to give me 0. So 2 minus 2 is 0, multiplied by negative 0.1. Well, that's still going to be 0, and then plus 2. So that whole thing is going to be equal to 2, and that's what I'm going to put here. So I get 2 for the y value when x is 1.9. Okay, let's do it again. So we're going to have y, which is 2, minus x, which now is 1.9, multiplied by negative 0.1, and then plus 2. Okay, so if you do the math right there, you should get 1.99, and that's going to be the y value when x is 1.8. Okay, and now here we'll do y minus x, so this is going to be 1.99 minus 1.8 multiplied by negative 0.1 plus 1.99, and if you do the math there, that's going to be equal to 1.971. So 1.971, and there you go. There's our answer right there. So that's what I'm looking for you guys to show, that you can find that number. Okay. Evaluate the integral using substitution. So first of all, what I'm looking for is something that I can use as a substitution. I'm looking at the numerator right there, because that's the same thing as the natural log of x raised to the 8th power. So my inside function would be natural log of x. So let's say u is equal to, I'll do this over here. So u is equal to the natural log of x. du is equal to 1 over x dx, and that means dx is equal to x du. Okay, so then whenever I rewrite this, I'll have the integral of u to the 8th divided by x, and dx is x du, so x du. And this works out kind of really nice because I have x in the denominator, x in the numerator, so the x's cancel. So I get the integral of u to the 8th, and then du, and that's I can integrate that right there. That's going to be equal to 1 over 9 u to the 9th plus c, and undo my substitution, so I get 1 over 9, and then I'll have u was natural log of x, so natural log of x raised to the 9th plus c. And there you go. Don't forget the plus c. Alright, continuing on, again, through substitution. This one seems quite easy to identify. U is going to be equal to x to the 6th plus 4. Du is going to be equal to 6x to the 5th dx. And dx will be equal to du divided by 6x to the 5th. Okay, so I have the integral of x to the 5th square root of u times by du divided by 6x to the 5th. I'm going to kick this 1/6 out to the front, so I'll have the 1 over 6 integral x to the 5th here cancels with the x to the 5th there, and leaving me with the square root of u. Now for the sake of the antiderivative, I'm going to say u to the 1/2 du. So when I anti-differentiate, I'm going to increase that power by 1. So I'm going to have 1 over 6. I'm going to have u to the 3/2 and a constant of 2/3 out here. Okay. Plus c. And then this is going to result in, that's going to result in, that's going to be 1/9, I believe it should be. Yeah, 1/9. So that's going to be 1/9 u to the 3/2 plus c, and undo the substitution, so 1 over 9, and my substitution was x to the 6th plus 4 raised to the 3/2, and then plus c. Okay. Evaluate the definite integral by making a u substitution and integrating from u of a to u of b. I'll talk about what this means right here, but really, any way that you want it. There's two different ways you can do this. I really don't care which way you do it. The question might be telling you to do it one way. I don't care which way you do it. I do like performing u substitute. So we're evaluating because we have bounds. I do like using this method right here. Okay, so u substitution. I'm going to make u equal to x plus 4. So du will just be equal to 1 dx. So that makes it pretty easy right there. Now, this is where we're going to remake our bounds, because these bounds are in terms of x. So x equals 1 and x equals 0. But whenever I rewrite my integral, I'll have the integral of x equals 0 and x equals 1, square root of u, and then this will become du. So my function is now in terms of u. My derivative is asking me to integrate in terms of u, but my bounds are in terms of x. So we're going to change that by plugging this x into this function right here to get a u value. So for my upper bound, I'll have u of 1. That's going to be equal to 5 when I plug that in. For my lower bound, that's going to be u of 0, which is going to result in, if I plug 0 in here, it's going to be 4. So now I'll rewrite my bounds. I'll have the integral, but now I have u equals 4 and u equals 5, square root of u du. So that's what the question is stating for you to do. Now, you can keep it in terms of x, but notice here is that since I'm just operating in terms of u, I am not going to undo my substitution when I anti-differentiate. Either way you want to do that, go for it. So if you want to keep it your bounds in terms of x, and then after you anti-differentiate, replace the u with x plus 4, go for it. It's up to you. Okay, so just for the sake of the integral, I'm going to say u to the 1/2. Okay, so this is going to be u to the 3/2 times by 2/3 from 4 to 5. So again, just if you were going to do the other method, this is where you would place x plus 4 right there, and then you would keep this with 0 and 1. But in any case, so this will be equal to 2/3. We would have 5 to the 3/2 minus 4 to the 3/2. 5 to the 3/2, that's the same thing as the square root of 5 times the square root of 5 times the square root of 5. And this right here would be 5 times the square root of 5. So this will be equal to 2/3 5 square root of 5 minus, and then this would be the same thing. It would be 4 square root of 4. Okay, but this is square root of 4 is 2, and so that's going to result in 8. So this is going to be equal to 2/3 times by 5 square root of 5 minus 8. Distribute the 2/3 to both of those. So that's going to be 10 over 3 square root of 5 minus 16 over 3. And that should be your solution right there. Okay. I would like this answer to be exact. I'm still debating on whether or not I would take points off if it wasn't, mainly because I just want to make sure that you guys aren't just using your calculators. So yeah, I think I like exact answers. All right. So for this one right here, we have this bound from 0 to pi, and a u substitution here. I think I'm just going to let u be this entire inside like that. So we'll say u is equal to 1 plus cosine of 5t. I'm just going to give myself a little more room. Okay, so du would be equal to, the derivative of that would be negative 5, because you have to multiply by the inside, sine of 5t. So I think that's what you want to do. Okay. dt, yeah, don't forget the dt. Okay. And then divide, so dt will be equal to du divided by negative 5 sine of 5t. Okay, upper bound would be equal to u of pi. Okay, so that means plugging pi in right here, so that would be 1 plus cosine of 5 pi. Really quickly, if you think about the graph of cosine, that's going to be 2 pi right there. That's going to be 4 pi. This is going to be 6 pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So it's going to be negative 1. So this is going to be equal to 1 minus 1, which will be equal to 0. And for a lower bound, u of 0 would be equal to 1 plus cosine of 0. Cosine of 0 is positive 1, so this will result in 1 plus 1, which will be equal to 2. Okay, so now I'll have my integral from 2 to 0. It's okay to leave your integral like this, but if you want to reverse them and make it negative, that's fine too. I think I'll probably do that in just a second. But in any case, I'll have u squared sine of 5t. And then dt was du divided by negative 5 sine of 5t. You can see that the sine of 5t cancels. I'm going to pull out the negative 1/5. So negative 1 over 5 integral from 2 to 0. Now, the integral from 2 to 0, if I replace that with 0 to 2, that's going to make this positive. So we'll get rid of that. And then I'll have u squared du. Okay, alright, so that's going to be equal to 1/5. That's going to be u to the third power and 1/3 from 0 to 2. So that's going to be 1 over 15. And then that's going to be u to the third from 0 to 2. So 1/15. That's going to be 2 to the third minus 0 to the third. That's going to be 1/15. And then multiplied by 8. So 8 over 15 is the answer there. Alright, evaluate the integral by parts. So by parts, meaning, so integral, it's going to be uv minus integral of v du. Okay, so all the u be equal to sine of x and v dv be equal to that. So I'll say u is equal to x. That means du is equal to 1 dx. dv is equal to sine of 8x. And v would be equal to, I think, negative 1 over 8 cosine of 8x. I believe that would be the antiderivative, because of the derivative of this would be negative. Yeah, that looks right. Okay. So my integral, this right here, would be equal to uv, so that would be the product of these two. So that's going to be negative 1 over 8x cosine of 8x minus the integral of v du, so multiplied by those together, so that's going to be the integral of negative 1 over 8 cosine of 8x dx. I think I'll be okay. Okay, so this is going to be equal to negative 1 over 8 cosine of 8x. I'm going to change that to plus 1/8, and then I'll have the integral of cosine of 8x dx. So all that's left for me to do is use the antiderivative of that right there. So negative 1 over 8 cosine of 8x plus 1 over 8. And then the antiderivative for this would be 1/8 again because of the chain rule. And then I think sine of 8x should do. And don't forget your plus c. So simplified, that should be negative 1 over 8 cosine of 8x plus 1 over 64 sine of 8x plus c. And that should be good right there. Okay, going up here, again, using parts. I wonder if I put any, yeah, I did, okay. So in this case right here, it would be easier to make u the natural log of 6x because the antiderivative of the natural log of 6x is complicated, well, I guess you could say more complicated than doing the alternative. So let's say u is equal to the natural log of 6y. The derivative of that would be equal to 1 over 6y multiplied by the inside. So it's just going to be 1 over y. So 1 over y would be the derivative of that, dy. Now dv we'll say is equal to y dy, and then v would be equal to 1/2 y squared. Okay, so this integral should be equal to u times by v. So we'll say 1/2 y squared natural log of 6y minus, the integral of, I'm going to write the 1/2 on the outside. So minus 1/2, I'll have integral of y squared times by 1 over y dy. And you can see that that's just going to result in y. So equal to 1/2 y squared natural log of 6y minus 1/2 integral of y dy. And the antiderivative of y would be 1/2 y squared. So I get 1/2 y squared, natural log of 6y minus 1/2, and then 1/2 y squared plus c. So 1/2 y squared, natural log of 6y minus 1/4 y squared plus c. And there you go. I think that's right. Okay, now going on to this one right here. This is probably a pretty difficult problem here. It's going to be using parts and solving the unknown integral. So we did a problem like this in class notes and like 1 or 2 in the homework. So just so you guys know, I would review those if you want more practice. So in these problems right here, it's best to use u as the exponential. So u is equal to e to the negative 5x. So that means du would be equal to negative 5 e to the negative 5x. dv would be cosine of x dx. And v would be equal to sine of x. Yes. Okay. Alright, so we have the integral of e to the negative 5x cosine x would be equal to u times by v. So that would be e to the negative 5x sine x minus the, 1 second, when I multiply this and this together, that's going to make it positive, because, so we'll do plus 5 on the outside, integral, so multiplying those together, that's going to be e to the negative 5x sine of x dx. Oh, I forgot my dx right there. Okay. Well, okay, so now I need to solve this part right here. So let's say u is equal to, again, we're going to have to do it again, e to the negative 5x. That means du would be equal to negative 5 e to the negative 5x dx. dv would be equal to sine of x dx. And v would be equal to negative cosine of x. Okay. Okay, so now let's say this right here. So I'll say I have the integral of e to the negative 5x sine of x dx is equal to uv. So I need to multiply those together. So that's going to be positive. I'll have 5e to the negative 5x cosine of x minus the integral of v. Oh, whoops! I multiplied the wrong ones together. Sorry. Sorry. One more time. So, so the integral of e to the negative 5x sine of x dx would be equal to u times by v. So those multiplied together. So that's going to be negative e to the negative 5x cosine of x minus, I'm going to multiply those together. Okay, so that's going to be positive, so that's not going to change the sign. That's still going to be negative, but I'm going to pull that 5 out. So minus 5 integral of u dv, so that v du, sorry. So that's going to be equal to e to the negative 5x cosine of x dx. Okay. So writing it all out together, going back up to this line right here. So this was the question, e to the negative 5x cosine of x dx. That's the question that we have right up here. So we started the antiderivative. This was equal to, so we did this whole process, and we got this right here. So we start with e to the negative 5x sine of x. Okay, so that's what we have right here. Plus 5. Okay, now here we had this, which we found to be this portion right here. So I'm going to substitute all of this in for what I have underlined in red here. So that's going to be negative e to the negative 5x cosine of x minus 5 integral e to the negative 5x cosine of x dx. So all of that. Okay, now I'm going to distribute that 5 to both of these terms. So I have this is equal to e to the negative 5x sine of x plus, now it's going to be minus 5 e to the negative 5x cosine of x, and then minus 25 integral e to the negative 5x cosine of x dx. Now, so this right here is equal to this right here. This is what we're trying to solve for, but we're getting the same thing right here. So this is the same thing as this right here. So I'm going to add 25 of this integral over here and make it 26. Okay, so I'll have, so put this over onto this side of the equation. So I'll have 26 integral e to the negative 5x cosine of x dx equal to what I have right here. Now, I'm going to call this e to the negative 5x because you see that both these terms have e to the negative 5x. I'm going to factor it out, so I'll have sine of x minus 5 cosine of x. That's a lot easier to write. And then in order to, this is what I'm trying to solve for, so I'm going to divide by 26, so I get that the integral of e to the negative 5x cosine of x dx is equal to e to the negative 5x sine of x minus 5 cosine of x all over 26, and there's our answer right here. So long as I put plus c. Okay, so that one's quite the problem. Alright, this is the last JK. We have 2 more pages. Okay, so use tabular method integration to find the antiderivative. Tabular method involves using a table. So I'll call this column I'll have as x to the third, and the other column I'll have as cosine of 8x. So cosine of 8x. I want to use this side as the derivative, this side as the antiderivative, because I want to exhaust the derivative. So x to the third, well, the derivative of that is 3x squared. Derivative of that is 6x. Derivative of that is 6. Derivative of that is 0. Okay, the derivative of cosine of 8x, that's going to be equal to, so you're going to need a 1/8, and I think that should be negative, no, it's not going to be negative, sine of 8x, that should be it right there. So sine 1/8 sine of 8x, okay, so that means the derivative of this should be cosine of 8x, which I believe it is. Now the next antiderivative is going to just be 1 over 64, because again we're going to have to use a 1/8, and this one will have to be negative, and then cosine of 8x. Okay, and the next one should be 1 over 512. This one would be sine of 8x, and this one would also have to be negative. Okay. And then for the next one, we would have to have 512. Let me make sure I'm doing this right. So 1/8, that's 8 times 8 is 64. Cosine of 8x, the derivative of that should give me that. Okay. And then I would have... Okay. Let's see. That's where I did wrong. Okay, I have this up one. I forgot to actually write this is going to be cosine of 8x. There we go. Okay, yep, I was thinking something was off. Okay, and then the next derivative should be 1 over that times by 8, which is 4096, and this is going to be cosine of 8x. So again, if you need to check these, just the derivatives of this should follow that down all the way to cosine of 8x. Okay, all right, and then for the tabular method, so this will be multiplied with this with a positive, multiply those with a negative, multiply those with a positive, those with a negative, negative. Okay, so then my answer should be equal to 1 over 8 x to the third sine of 8x. Okay, and the next one would be equal to, and then let's see, so I multiply those, that's going to turn into positive, so plus 3 over 64 x squared cosine of 8x. And then when I multiply those, that's going to be 6 over 512, which is going to reduce to minus 3 over 256. And then I'll have x, and then I'll have sine of 8x. Okay, and then here is going to result in 6 over this, which will reduce to 3 over 2048. Yep. No x, and then cosine of 8x, and then plus c. So that should be your answer there. Okay, so use separation of values to solve the initial value problem. So separable differential equations. So as I see here, I have dy over dx. This is in terms of x, this is in terms of y. So I'm going to multiply this over here. I'm going to multiply that over there. So it should be 3y plus 4 dy equal to 3 minus x to the fourth dx. And then I can anti-differentiate because I have my variables separated. So this will be 3 over 2y squared plus 4y equal to 3x minus 1 over 5x to the fifth plus c. I have an initial point right here, so y is going to be equal to 1. So that would make this 3 halves plus 4 equal to x is 0, so that's just going to be 0, so it's going to be equal to c. So this is 3 halves plus 8 halves, and so it looks like c is going to be equal to 11 halves. Now there's no way you're going to solve this for y by itself, so you're just going to leave it like that. So 3 halves y squared plus 4y is equal to 3x minus 1/5 x to the fifth plus 11 over 2. Again, there's no way you're going to solve that for y. You're going to isolate y. It's not going to happen, so that's good right there. All right. So it says Jorge invested $9,500 at 4% compounded semi-annually. In how many years will Jorge's investment have quadrupled? Round your answer to the nearest tenth. So we're looking to use A is equal to P times by 1 plus R divided by N raised to the NT. So we want to use this formula right here. Now we're looking to see how long, so we're trying to find T when it's been quadrupled. This is kind of irrelevant. We just need to know when A is equal to 4, essentially. When does the principal amount quadruple? And then we'll have 1 plus the rate, which would be 0.04 divided by N, which is semi-annually, so that would be 2, and then raised to the 2t. So that's going to be, so that would be 4 is equal to, so if you punch this into a calculator, that's going to be 1.02 raised to the 2t. Okay, I'm going to take the natural log of both sides, so I'll have the natural log of 4 is equal to the natural log of 1.02 raised to the 2t. I'm going to drop that down to be a multiplier. So I'll have the natural log of 4 is equal to 2t multiplied by the natural log of 1.02. And then I'll divide by 2 and natural log of 1.02. So I'll get t is equal to natural log of 4 divided by 2 natural log 1.02. I believe that's right. So if you punch that into a calculator, you should get, when you round, should be 35. Don't forget your units. So 35 years. Okay. Coming up here, how long would it take a $7,000 to grow to 28,000 at 9% compounded continuously? So a is equal to p e to the rt. I believe that should just result in 4 because that's 4 times larger than that. So 4 is equal to e raised to the 0.09t. We're solving for t. Take the natural log of both sides. So you get the natural log of 4 is equal to 0.09t. And you'll get that t is equal to the natural log of 4 divided 0.09, which should give you about 15.4 years. Alright, a colony of bacteria is grown under ideal conditions in a laboratory so that the population increases exponentially with time. At the end of 3 hours, there are 32,400 bacteria. At the end of 5 hours, there are 291,600 bacteria. How many bacteria were present initially? Looks like we're going to have to use 2 equations here. So 291,600 bacteria is equal to, we don't know the initial amount, e raised to the, we don't know the rate either, so r times by, in this case it'd be 5 years, but we also know we have 32,400 bacteria is equal to the same thing, but this would be in, sorry, not years, hours. Okay, so we're going to divide these equations. So we divide those, because when I divide these, those are going to cancel, and then those are going to subtract. Okay. Alright, so when you divide those, you should get 9. So 9 is equal to, those are going to cancel. That's going to be e to the 2r. Because 5 minus 3 is going to be 2, so 2r. So it looks like we're finding the rate first, so I'll take the natural log of both sides. So natural log of 9 is equal to 2r. So r will be equal to the natural log of 9 divided by 2. So r is equal to 1.0986. The more decimal places you keep, the better your answer is going to be, ideally. Alright, so now that I know that r is that, and now we want to find y sub naught, I can plug r into either one of these. I'm going to use this equation because that's a smaller number right there. So I'll have 32,400 is equal to y sub naught e to the, I'm just going to, yeah, sure, why not, 1.0986, and you can plug this part right here into a calculator, so you get 32,400 is equal to y sub naught. So you plug that part into a calculator, so e raised to the 3 multiplied by 1.0986 turns out to be pretty much just 27, looks like, so multiplied by 27. So y sub naught would be equal to 32,400 divided by 27, which comes out to be it's at 1200. Yeah, so 1200 bacteria. Okay, so make sure you're familiar with this formula and this formula right here, and you understand exponential growth. All right, Newton's law of cooling. Now, I'm going to be honest, I'm leaning towards just giving you the equation for the test. So keep that in mind. So it says that a dish of lasagna baked at 400 degrees Fahrenheit is taken out of the oven into a kitchen that is 69 degrees Fahrenheit. After 7 minutes, the temperature of the lasagna is 300 K. So, it looks like the surrounding temperature is going to be equal to 69 degrees Fahrenheit. Let's see. So the temperature would be equal to 333.6 degrees, and that's 7 minutes. It's after 7 minutes. Okay, the initial temperature is the 400 degrees when it was in the oven. Okay, what will be the temperature? What will its temperature be 16 minutes after? Okay, so the equation goes as follows. So 33.6. So we have T minus the surrounding temperature, so 69, equal to, we're going to have the initial temperature now, so that's going to be 400 minus the surrounding temperature, e raised to the negative k times by t, which would be 7 minutes. So we don't know k, so we can find that. So if we do 33.6 minus 69, that's 264.6 equal to 400 minus 69. That's 331 e to the negative 7k. I can divide by 331, so I get 264.6 over 331 equal to e to the negative 7k. I'll divide, I'll take the natural log. So the natural log 264.6 divided by 331 is equal to negative 7k. So the constant will be equal to the natural log of 264.6 divided by 331, and all of that divided by negative 7. Okay, if you plug that all into a calculator, okay, so should get constant is equal to about 0.0. I'm really just going to be using my calculator for this, like storing these values in my calculator so that I don't have to round. But you should get like 0.0319, we'll say 99. Okay, so now that you know the constant, going back to the formula, we're trying to find the temperature after 16 minutes. So that's going to be T minus 69 is equal to, this is still going to be 331. Then we're going to have e to the negative k times by 16. Remember that this is the constant k. So temperature will be equal to 331 e to the negative 16 k plus 69. So you can punch that into a calculator to get your temperature. Okay, and if you do that, I'm just keeping the calculator constant. Okay, so that's a 267.4 degrees Fahrenheit. That should work. Okay. Alright. moving along, find the solution to the differential equation dy dt is equal to kt. K is a constant that satisfies the given conditions. So remember, if this is your differential equation, the solution is the exponential kt, I guess you could say. So you can see that the initial value is 3907, so that's going to be that right there. So y is equal to 3907 e to the negative 2.5 because that's the given k value, t, and that should be it right there. Looking at the key, that does look to be correct. Okay, so very easy for that one. All right, evaluate the integral. This is looking to be partial fractions because I have polynomials, and this is factorable. So 4x plus 46 divided by, that's going to be x plus 1, and x plus 7, I believe, should be correct. X squared plus 8, yeah. So that's going to be equal to a over, we'll say x plus 1 plus b over x plus 7. And then we'd multiply the entire thing by x plus 1 and x plus 7. Okay, so 4x plus 46 will be equal to a times by x plus 7 plus b times by x plus 1. So let's say x is equal to negative 1. Okay, so if x is equal to negative 1, that's going to make it negative 4 and 46, so that should be 42 equal to a times by, that's going to be 6 right there. Okay, so that means a is going to be equal to 7, right? Yeah, so a is going to be equal to 7. Okay, let's say x is equal to, in this case, we'll make it negative 7. Okay, so if x is equal to negative 7, that's going to be equal to 4 times negative 7 plus 46. So looks like we'll get 18. So 18 is equal to b, and then we'll get 6. Okay, so b should be equal to 3. Okay, so we're evaluating 7, the integral of 7 over x plus 1 plus 3 over x plus 7. Yeah, I believe that's correct. Okay, dx. So this will result in 7 natural log of x plus 1. Okay. I'm double checking my work. Hold on. I feel like something's off right here. So x is equal to negative 7. That's going to be negative 6. There we go. That's something fell off right there. So negative 6. That's going to make that negative 3. So that would make that negative 3. Okay, that looks right. Okay, minus 3 natural log of x plus 7 plus c. Okay, I would be okay if you left it here. If you're looking to simplify a little bit more, that'd be the natural log of x plus 1 to the 7th minus the natural log of x plus 7 to the 3rd plus c, and that would be equal to the natural log of x plus 1 to the 7th divided by x plus 7 to the 3rd plus c. Okay, that's looking good. Next one also looks like it's a partial fraction. So 9x minus 16 over, looking to factor that. So that would be 3x. We need an x. So that would have to be plus 4 minus 1. That would give you 3x squared. That would give you positive 12 minus 1, which is 11x. Yeah. So that'd be a over 3x minus 1 plus b divided by x plus 4. Okay, multiply the whole thing by 3x minus 1 and x plus 4. So I get 9x minus 16 is equal to a times by x plus 4 plus b times by 3x minus 1. Alright, let's see. Let's say x is equal to 1/3. Okay, that would make this 3 minus 16, which would give me negative 13. And that would give me a, and then that would give me 1/3 plus 12/3, because that's 4. So I get negative 13 is equal to a times by 13/3. So a should come out to be negative 3. Okay, so let's say x is equal to negative 4. So that would be 9, negative 4, minus 16. So that's going to be negative 52 is equal to b, and that would be negative 13. So then b would be equal to positive 4, right? 52 divided by 13. Yeah, positive 4. Okay, so since this was negative, I'm going to write this term last. So I'm evaluating the integral of b, so 4 over x plus 4 minus 3 over 3x minus 1 dx. Okay, so this will give me the natural log of x plus 4, 4 natural log of x plus 4 minus, now that would be 3 natural log of 3x minus 1, but I'd also have to multiply or divide by, I would have to divide by 3 because of the constant there. So those would cancel right there, so don't forget the plus c. So I'd have the natural log of x plus 4 minus just natural log of 3x minus 1 plus c. That would be an acceptable answer. Sorry, that should be to the 4th power. You could also write it as the natural log of, you could say, absolute value, we'll do x plus 4 raised to the 4th over 3x minus 1, and then plus c. Okay. Okay, this shouldn't be too much longer. These problems should be pretty quick. So the logistic differential equation here describes the growth of a population where t is measured in years. So find the carrying capacity. Carrying capacity would be 1800. So 1800. B, find the size of the population when it is growing fastest. That would be at half the population. So at 900. Find the rate at, when the population is growing at its fastest. So we have dp divided by dt, fastest. That's going to be equal to 0.0009 times by 900, and then 18 minus 900 is 900. So if you punch that into a calculator, I get 729. And since we don't really know what units we're using, I guess you could say, I don't know, population units per year, since it's a rate. Okay, that should be good there. The growth of a population is described by the logistic differential equation given there. Okay, where t is measured in years and p is equal to 10 when t is equal to 0. Solve the initial value problem. Not using partial fractions. Just solve it. So if you guys recall that the solution, p of t is equal to m divided by 1 plus a e to the negative mkt. That's going to be the solution. So m is 1400, k is 0.0004. We need to find the value of a. So we have p of t is equal to 1400 divided by 1 plus a e to the negative. Now you can multiply m and k together. So when you do that, you should get 0.56 t. Okay, now let's apply the initial condition so that we find the value of a. So p is 10, t is 0. So we'll have 10 is equal to 1400 divided by 1 plus a. Now, if you plug 0 in here, that's going to be 0 here. That's going to be e to the 0, which is just going to be 1. So I'm going to multiply both sides by 1 plus a, and then I'll divide the sides by 10. So that's going to be 140. So it seems like a is going to be equal to 139. So p of t is going to be equal to 1400 divided by 1 plus 139 e to the negative 0.56 t. And there is your solution right there. Okay, that should be everything for this review. I know it's a kind of lengthy review. I'm not going to have this many questions on the test. I just wanted to make sure that you guys got as much antiderivative practice as possible. So I would expect any type of these questions to come up on the test, just not all of them. Okay, let me know if you have any questions. Thanks, guys.